Etorkizuna eraikitzea prozesuak berak kreatibidade zaparra da, eskatzen du, oso konplexua baita. Eta diseinadore baten erara pentsatu beharra. Diseinatzaileek erantzunak edo irtenbideak proposatzen dizkiete etengabe bizitzak planteatzen dituen erronkei. Eta horretan da hain zuzen ere aditu gure lehenengo gonbidatua Mickey Mcmanus, ongi etorri eszenatokira. Welcome to Basque Country, Mickey. We are born creative, very creative, but somehow we lose that creativity. It's very hard for us usually to work in teams, but it's required nowadays to face the future. How can we do?
First of all, Kaisho. Vanessa, I think it's a great question. How do we work together? How do we co-create? And I think that's one of the ways we have to think about how we will move forward, is not coming up with an idea and then feeling good about the idea. Ideas are pretty easy to come up with. Big ideas are easy to come up with. Details are really hard. And the only way we learn about the details is by doing something. We have to make something and learn and co-create. So a lot of what I'll talk about today is sort of how do we create a space for creativity? How do we give ourselves room to work together with people? And maybe use design methods that we all can learn to actually think that way. So that's a little bit of it. But it's not an easy journey. I think everyone's on a long journey, but there are real ways we can do this and some design thinking methods that could help us along the way.
We are ready to hear.
All right, thank you.
Welcome, thank you.
So this morning I thought I would talk about different ways that we could create space for creativity, for curiosity, and for innovation. Vanessa brings up a really good point, and I think a lot of the purpose of this Building the Future is to engage with all of the stakeholders. And so the question is, how do we put people first? Because we've really entered this era, if you look at the Industrial Revolution, we've entered an era where we can kind of make anything, and we can make it right. We've really gotten to the point where we can kind of dream something up and we can manufacture it, we can make it. Which shifts the topic, I think, to what's the right thing to make. And when you say what's the right thing to make, you have to say the right thing for who? We have to pay attention to people? This is something that's a little different. And so how do we put people first? And I would tell you that if you look at the characteristics of creative people, you find lots of words. You know, you find that they're empathic and they're persistent and you know, they have a curious mind. And there are a lot of books written about all the different characteristics of innovative, creative people. But they don't often help you figure out what you should do. What could you do tomorrow to actually do this? And I think that there are a collection of methods, and sometimes they go by the words design thinking or design or human-centered design, that are the methods you use to actually put people first. So one of the first methods is looking. It's going out and looking and listening and finding unmet needs, finding unvoiced needs, because sometimes people even don't know how to put it into words. Another collection of techniques have to do with understanding. How do we not just react to the symptom, but how do we actually do something about it and get to the root cause of the problem? How do we understand how we're doing something, but also abstract up to why we're doing something? So there are a lot of collection of methods around understanding and understanding our stakeholders, understanding the challenges they're facing. And then finally, making. How do we actually engage in making things? How would we prototype this in a way that isn't, you know, the reason it's a pilot and not just going ahead and changing policy is that the pilot says we're going to take a little safe space and we're going to simulate and prototype what might happen, so that we don't affect a giant population with our crazy idea. We're going to make it first, and we're going to iterate a little bit and learn what happens when people are in those worlds before going off and doing something big. So when people talk about design, in some ways it's the discipline of generating new solutions to problems and making solutions along the way. The act of making teaches us something about the world. We try out a policy, we try out a new product, we think about a new manufacturing approach, we think about a new way of educating people. When we say human-centered design and the design thinking movement, it's really about doing all that, but in the context where it's being driven by the needs and the desires and the context of everyone who's involved. So putting people first, effectively. Now, a lot of people say, oh, well, great, let's go ahead and do a survey. And surveys are fine, but they're not design. If I go talk to 100 people with market research, I might get 5 insights. So I don't get a lot of insights from it. I hear a lot of what maybe they want to tell me, but they might not actually be able to articulate. Margaret Mead once said, what people do and what they say they do are very different things. And market research often just tells us what we actually ask them back to us. It doesn't tell us anything new. But the other thing we could do is we can do ethnographic research. We can go out into the world and we can actually talk to a few archetypal stakeholders. This is a few people, but we can get many insights. From 10 people, maybe I can get 100 different insights. From a few pilots, I can learn thousands of different things. So it's really the inversion. And the reason I say ethnographic research, which is a kind of going out and studying and talking to people, is that I can look in context. I can see, this is the way the person works. I can observe the culture. I can see the systems in play. I can look at the symbols. I can understand their behavior in context, and I can understand the meaning of the process. So all of these techniques are one way that we can use to learn things. And here's a collection of those techniques. A few years ago, I built an educational institute called Luma, and it was all about looking at 1,000 techniques over the last 100 years and thinking about what we could learn from those techniques. And there are a collection of techniques of looking and listening. Could we go out and interview? Could we do something called contextual inquiry, where we go out into context of people's lives and say, I'm observing this, I'm shadowing you. Why did you do that? Why did you do this? So you learn along the way. And there are a collection of techniques for understanding, something called stakeholder mapping, experience diagramming. What is the experience people go through? So there are a whole bunch of these. And then there are techniques for making. How do you iterate? How do you come up with new ideas? So to give you an example, interviewing is going out and just talking to some of the stakeholders. Contextual inquiry is going out into the field and actually seeing what the community is going through, how they're living. Fly on the wall is just observing and just not asking any questions, just watching over time to see if you can see patterns. And then also sending out some of the people doing the pilots and saying, how about you walk a mile in someone else's shoes? Walk a kilometer in someone else's shoes. So here's an example. This is a young designer that he's trying to understand what it's like when you have cataracts, when you have eye problems, and when you have arthritis. So he actually has gloves that have needles in them that actually stop him from moving his hands completely. And then he has glasses that have been sanded so that he can't actually see very well. And now he's actually trying to open the product. He's trying to try out some activity. This is a way that we can do things. Or go out into the field and actually see how the different industries are interacting with their workers and how the laborers are learning new things and what's happening in the process of doing the work. The other thing that we can do is we can iterate really quickly. And iteration, just coming up with an idea, trying it, learning from it, failing, learning again, and learning quickly is another thing we can do. So this is an example of what's called paper prototyping. Instead of writing a bunch of code for a new website or for a new app, you can just draw all the pictures on paper. And when people touch on a button on the paper, you change the paper. So you just iterate in an afternoon. You can come up with ideas, you can go test them. And when people click on them, you can hear what they say and what they think. If you do this right, you can end up with some pretty dramatic changes. So this sort of design thinking is now becoming very important in major corporations, in major industries. In the United States, the Obama administration took all these Luma techniques and they taught over 2,000 of their government employees design thinking. And they said, how could we apply these? And if you do it right, you can really be more citizen-centered as well. This is an example of a company that applied these ideas. They learned how to do it themselves. They weren't designers, but they learned the techniques, and they focused on a piece of software that runs an entire factory. And in the process, they said, well, we'll never be able to make it better than 10% better than the software. We've worked on this for years. This is a great product. It's very successful. But by applying these, it fit better into the way people think, and they got 82% reduction in task, which meant they could suddenly do a lot more with a lot less by applying these techniques. If you look at public institutions like the post office, where we get our mail, most of the systems are built around the machinery of the systems. You've got buildings with brick and mortar, you've got vending machines and phones and online, and things like that. But the customer sees it as, I want to send cookies to maybe somebody, to a family. I want to send a wedding invitation. They have actions they want to take. So we don't want to really expose all this junky background stuff to people. We want to say, how can we actually be more user-centered? Think about the goals they're trying to reach, and how do we actually focus on those goals? So I'll give you an example of also how you can be creative with these techniques. About 2 years ago, we worked with a local neighborhood community, and we said, how could we facilitate an evening session with a lot of different stakeholders? So these were council members from the local government, but also moms and dads and kids and parents and local educators and local businesses. And we said, could we look at a way to impact this neighborhood, and could we do it in just a few hours? And so we took a few of those techniques, contextual inquiry and affinity clustering and thumbnail sketching and creative matrix, and we actually had everyone learn those techniques in an afternoon, and in the evening they actually applied them. So this is something called a creative matrix. You put possible enabling ways you can do things on the side, and you put different challenges along the top. And over the course of just a few, maybe 20 minutes or 30 minutes, people generated different ideas at the intersections of these 2 points. So 43 people with 9 teams generated 797 ideas in 20 minutes. And then they focused on how we can actually think about how to build on other people's ideas. How could we improvise on those ideas? And then they looked at how important the ideas were. Would they make an impact in the neighborhood? How difficult were they to actually do? And they looked at those sweet spots. If it's really important and not too difficult, we could do that tomorrow. If it's really important but really difficult, that might take a real big pilot. So it allowed them to prioritize their challenges. And then they came up with a timeline to think about how they could get the project done. And then we did sort of a little bit of a science fair where everybody was able to tell their stories and convince each other about what best thing to do. And then they went off and did it. And within a month, they actually did this activation in their neighborhood. And it helped bring more people to the neighborhood, and it helped actually build more of a community. Ultimately, design thinking is about engaging with stakeholders, but using these techniques. There's a science to this, a design science to it, that you can actually learn from things. It's also iterating. How do you do these pilots and learn fast? And then it's really interdisciplinary. You can't all be politicians, you can't all be just parents, you can't all be educators or business people. You have to work together with people that think differently than you. Because most of the time, the really good answers are at the intersections of different disciplines, different ways of thinking. All the easy answers are over. This is a hard challenge, and so you have to look for that. So that's one thing we can do. We can put people at the center. And there's a whole collection of techniques, and that might feel overwhelming, but it turns out in a day or two, you can learn these techniques. In the Pittsburgh region, where I spend a lot of time, we use those techniques, and we built an entire kids and creativity movement. So now there are children in maybe 10 or 11 years old that are learning these techniques, and they're applying them in their local community. And we recently used these techniques to come up with an idea that was with foundations and very large companies and the government, and we put together over a $100 million fund that said if kids learn these things and they're in high school, we will give them a full ride through college. And it's called the Pittsburgh Promise, and it's actually bringing more young people to the city. So we've now had a net influx of 20-something, 30-something people bringing their kids to the city because they actually want to be a part of the future of that city. So we're using these techniques, and then we're saying we're going to invest in the future with our children so they learn this new kind of literacy. Now there's another kind of space we have to create. We have to create space for all these technological disruptions because there's so much going on and it's going so fast. So how do we think about all these technologies that are coming at us? And they seem to be coming at us faster and faster all the time. How do we create space for all this disruption? And how do we look at things that yesterday we thought were impossible and that today are possible because of a new technology? And I want to give you a sense of how this feels when you try to start embracing with disruptive technologies. You know, in a sense, this can be the most overwhelming part because every day we hear about machine learning, we hear about 3D printing, we hear about, you know, the new cloud computing possibilities, we hear about all sorts of disruptions, augmented reality, et cetera. In a sense, we're entering an era that is very complex, maybe more complex than it's ever been in the history of the world. And you are here. You know, you're right in this moment of the rise of complexity. And there's more and more complexity between you and trying to solve problems than ever before. It's a noisy world, and it's getting noisier and noisier. And if you looked back 100 years ago, only a few people had to cope with a lot of complexity. Maybe somebody building a big factory, Henry Ford, trying to figure out how to do the Industrial Revolution. There were very few people that had to deal with it. Maybe just big countries or big enterprises could even afford one computer 50 years ago. But today, everybody's coping with complexity, and more people are coping with it than ever. Your computer in your pocket has more power than most presidents and most large companies had a few years ago. So we have more and more complexity than ever. And it's because we're connecting the entire world. It's this ability to connect everything. A few years ago, I wrote a book called Trillions, and it was based on my laboratory's research into what happens when we connect trillions of things together. And that's kind of intimidating, but it turns out we're less than 5 years away from having 1 trillion connected devices. In just 2010, we made more transistors than grains of rice. So many transistors, and we made them cheaper than rice. Also in 2010, we made more chips, microchips, and computer chips than people on the planet. We made 10 billion in 1 year. So there's a rise of computation all over the place. And it's sort of like we're going from information in our computer, information in our phone, in our supercomputer in our pocket, to us living in the information. We're going to have trillions of these things scattered throughout our lives, and they're all going to be talking to us. So it's the rise of a very large amount of complexity in the world. And this is the malice that our society will be facing, is all that complexity, and your children will be facing. It is a complex world. And it's not 1 trillion €1 notes or $1 bills. This isn't 1 trillion of the same thing. This is 1 trillion things that all have the ability to send you 1 billion messages. This is 1 trillion things that can get a bad update or can maybe have malicious intent. I don't know if anybody remembers the Internet of Thing device about a year ago that started lying when people drove it and when it was being tested to see if it was actually an efficient diesel. It was a company called Volkswagen, and they made a little line of code inside of their cars that basically said if I'm being tested by an environmental agency, I should lie about how efficient my car is. Now that was a big deal. They basically put little bits of code in things and gave it malicious intent. Most recently, a whole hospital was taken down in the UK because they turned a lot of the energy and power plants into basically hostages by putting little bits of code in these Internet of Thing devices and turning them off until you paid the ransom. So this is an era of unbounded complexity. Now that can be scary. So it's kind of nice to say, how do I think about this complexity? And one way to think about that is to look at other systems that have had this kind of complexity before. It turns out our bodies are complex information systems in their own right. We can actually look at nature and try to understand design patterns that we could use to actually make a thriving society. And I'll give you one example, or maybe 2 examples in nature. Your body, every one of you, is a complex information system. You have over 50 trillion cells in your body. And if you look closely, our bodies are made of atoms, and those atoms make up molecules, those molecules become cells, those cells become organs, those organs get together and become systems, those systems get together and if we're really lucky become me, and then you and us, and those become a community. And that's a pattern in nature called layered complexity or semantic layering. There are stable plateaus. Atoms don't know how they're used as molecules. Molecules don't know how they're used as cells. They're stable so that they can evolve quickly. This layered approach is one design pattern that helps us deal with the fact that we have trillions. Every one of our bodies here have between 50 and 100 trillion cells. And yet you're very resilient. You'll go 70, 80, 90, 100, maybe longer years without a catastrophic failure. If you cut your leg, it does not call the cloud up here to solve the problem. It turns out every single cell in our body has a spare copy of us in the form of DNA. So nature chose peer-to-peer replication so that we build scaffolding, our skin starts to fix the problem, and then there's a layer called the circulatory system or the nervous system. But if we had to rely on calling the brain every time we forgot to breathe or every time we cut ourselves, we would be in trouble. And so this idea of how we can study design patterns in nature give us a way of putting space around complex new technologies. Nature's been there before. Here's one more example out of nature that I think is a little telling. How many people have ever heard of Pando? Has anybody heard of Pando? I don't think so. Okay, so this is Pando. It's a stand of quaking aspen in Utah, in the United States. And it's been alive for 75,000 years. And it's one tree. It covers hundreds of kilometers. And when one leaf changes, all the leaves change, because it's only one tree. It actually grows by shooting a shoot under the ground and shooting back up a tree, and then shooting under and shooting back up. But it could not survive all by itself. It's the oldest living organism on Earth. What's the pattern we can find in this? And it turns out that just below the surface of Pando is what they call a mycorrhizal network. Myco just means fungus, and rhizal means horizontal. So a horizontal network that weaves together oak trees and grass and aspen, this is a quaking aspen, Pando, and a bunch of other things in the forest. And it moves water over kilometers from areas of abundance to areas of drought. It actually takes carbon atoms from the oak and it moves them to Pando to give it food. So almost 80% of all the plant life on the earth has mycorrhizal networks. It's almost like the internet of plants. And it's been going for 75,000 years. And we can study that. It's a form of symbiosis called mutualism, where it's good for me and good for you. And it builds on each other. I think of these patterns as beautiful complexity instead of sort of malignant, scary complexity. So that's one of the ways we cope with new disruptive things, is we look for patterns in other systems so that we can see if there's something that gives us a handle. So we're not just reacting to the tip of the iceberg, but we're actually thinking about what the actual pattern is beneath the surface. In the book, we covered a lot of different ideas. So I won't cover many of them today, but I think ultimately, if you get over to that big mountain of trillions, it turns out there's a lot of business value and there's a lot of social value to it on the other end. So entire new businesses will rise. We think we're just hitting the end of the Industrial Revolution and now Industry 4.0, but it turns out there will be whole new opportunities for this region to thrive if we really embrace it and understand it. McKinsey recently put out a report and said there will be between $3 and $11 trillion contributed to global GDP by 2025, just with the Internet of Things part of trillions. When we start collecting things and we actually start harvesting all that data and trying to make them more efficient. You know, when I wrote the book, I thought it was just going to be a sea of information devices. I thought that was pretty complicated. A lot, you know, the Internet of Things, plus, everything connected. But it really turns out that there are all these megatrends that are overlapping each other and kind of churning together in a bit of a soup. It's not just a sea of information devices. It's actually that they all have opinions because there's machine learning, this artificial intelligence running on those things, and they've got sensors so they can test things out on their own and learn new things, and digital manufacturing. These things can actually choose to get a hardware or a software update automatically. That's a really big thing, and I think we have to get our head around this kind of new disruption. And I'll give you a little taste of what those disruptions look like. When I say digital manufacturing and robotics, this is what you might hear of as 3D printing, but it's really changing things, because it's not just plastic. 3D printing a lot of Star Wars figures like Yoda heads or something, which we see with our kids, but it's a whole bunch of other things. Companies now, automotive companies, are saying, I can machine and mill and make this carburetor for my car, but it weighs 5 kilograms and it has 823 centimeters squared of cooling, which means it's going to be more energy efficient. But with 3D printing, I can make it only weigh 1.9 kilogram, and I can actually have 10,000 centimeters squared of cooling surface. So from an economic standpoint, it's flipped over to it's actually more cost effective to make things 3D printed out of titanium and out of aluminum alloy. That's 3D printed with a little laser sintering than it is to actually machine it the old way. I recently worked on a project where we tried to say what would happen if 3 kids in a garage could start a new car company. Is it only going to be giant car companies that run the world, or only really rich billionaires like Elon Musk? Could 3 kids in a garage start a car company the way 3 kids in a dorm room started Facebook? That was the question. And we started to apply these things like machine learning and digital manufacturing to the challenge. And in a very short time, we ended up with something very interesting, and I'll show you a little example of that. in this case, that's Felix. He's designed cars for 30 years. That's Mouse. He's actually raced cars. He's a motorsport champion. He's won 5 Guinness records. And we worked with them to design a new car, even though they'd all worked on cars their whole life for a motorsport car. And we actually had the system evolve it over time. The designers didn't draw the chassis. The designers drew the arrows that said these are the forces acting on the chassis. And we started having the system evolve new things. So it was this weird thing where we took advantage of brand new disruptive technologies, and the car started dreaming of its own future. And the car started coming up with ways that it could actually lightweight itself and make it lighter. And it turns out by the end of this process, even though we had had it designed by people who had done 40 years worth of motorsports and they won records around the world, this car was 30% lighter. And it was because the car was able to actually be a part of the process. We had Internet of Things sensors on the car. We drove it in the desert. We sensed things, captured about 4 billion data points every afternoon. And we mostly did this with interns. So this was all done with the next generation, where they casually collected 4 billion data points in an afternoon. This is what the car is looking like today. General Electric, GE, recently took a Cessna engine. This is a turbo prop engine, and they took a bunch of their engineers and they put them in a room and they said, you can't leave until you come up with a way to use new kinds of manufacturing technology. And so this engine has about 2,000 parts. They took 855 of those parts and they boiled them all down to only 12 parts. So they took 855 traditionally manufactured parts, traditionally negotiated relationships with suppliers and vendors, and they reduced it down to 12 parts that are just files on a computer. And when they need them, they print them. So they don't have all those contracts, they don't have all those things. It radically changed the way that they think about things. So digital manufacturing is pretty dramatically changing things. Imagine that, taking an engine and going from 855 parts to 12 parts and nothing in the warehouse, no warehouse. Just a computer file, and you 3D print the part when you need it. So this is probably going to radically change the way we even have relationships with all the different networks in our supply chain. A friend of mine worked on a project, she's in the audience somewhere here, where they actually shipped a 3D printer to the International Space Station, and they emailed a wrench to the mission commander. So instead of putting all the stuff you need on a rocket, on a big, basically, explosion and hoping it can get up there, they emailed a wrench. This is an example of some of the test flights they did. This is what it looks like. And this is Butch, who's the mission commander on the space station, who didn't know it, but he said, oh, I've got a socket. I wish I had a wrench that worked with this. And the next morning, that wrench was on the 3D printer, and he snapped it off, and it worked. So we're able to, for the first time in history, manufacture off-planet. That's kind of amazing. And in fact, recently they ran a competition where high school kids were able to actually design something that was printed in the space station so that they could actually learn and play and interact with astronauts. So this is kind of stunning. And even these kinds of digital manufacturing approaches are being disrupted. I recently met, and I'm an advisor to a small group in Rome, who did a little Kickstarter campaign to say, what if 2 billion people have a 3D printer in their pocket? Or what if 2 billion people have half a 3D printer in their pocket, and the other half only costs $99? What if you could text message a physical thing to somebody? So this is what that looks like, and they're going to be shipping it probably within the next few months. You put this down on your phone, and you pour a little bit of resin into the phone. It's got a protective layer so it doesn't destroy your phone. And you put this little piece down, and you plug in the USB port, and in about 2 or 3 hours, someone can text you a message, and 2 or 3 hours later, it actually prints it off of your phone, and it emerges out of the goo. This is $99. So massive disruptions coming ahead, and then how do we think about these things, and how do we learn from them? Even infrastructure is being changed. This is sort of a toy, but it's kind of interesting. If you have an iPad Pro, you could have multiple build plates, and you could build all the soft things, all the transparent things, all the mechanical things right on your desktop. We're also seeing this for public works. This is an effort done by an artist that we're working with in Amsterdam, where they said, could we put 2 robots on the side of a canal in Amsterdam and push a button, and could the robots weave a bridge where the bridge needs to be? And so they're now about a third of the way through. This is using robotics to actually manufacture a new bridge that's going to be in place in Amsterdam. So it's pretty wild to look at these things and say, okay, how can we get our head around them? Now this is interesting. And they're starting to actually sense up the existing bridge now so that they can learn about how people flow over the bridge. This is going to be in the red light district of Amsterdam. But what happens when public infrastructure can be refreshed casually and easily rather than a giant project that takes many years? What happens when you can actually have things that evolve based on the real feedback from users and from the community? This will be fun to watch. I think they're going to install it early next year. Another disruptive technology is machine learning, and I think it's really important to try to open up your head to understand what this looks like and how it works, because I think it's going to impact us in many ways. Many people think about artificial intelligence and machine learning. Maybe they think about the self-driving car. This is Mercedes. I think their idea is that you'll probably just have a cocktail party in the car, so they've got a cocktail tray there. What's the point in having a driver? But we're actually starting to see machine learning being applied for public policy and for health. So here's an example where a small group of entrepreneurs inside of the government of the United States, inside of the Center for Disease Control, over weekends, they were challenged with a little bit of a pilot challenge, and they said, could we actually detect autism rates in our population? And so they looked at autism rates, and they said, could we take open source software that does machine learning, and could we apply it to all the data we have from birth until 6 years old in different sites across the country? Normally, that takes 1,700 hours to analyze a site by professional analysts. In the course of about a month or two, they got it down to 1 second to be able to actually analyze the sites with 87% agreement with the analysts. So suddenly, with a little off-the-shelf software, with people that don't know much about machine learning, but they knew a lot about autism rates in the Center for Disease Control, they had built something that actually saved 1,700 hours worth of time so that they could have those analysts work on much more important things. We also have little chips now that are actually programming. You program the chip or you raise the product by actually not writing any code at all. You just raise it like a child or like a dog. In this case, this is a little chip called a zero chip. It's about a $10 chip, and you don't write any code. You basically say good dog, bad dog. When it goes over the white square, you say good dog, you give it a carrot. When it goes over the other squares, you give it a stick. And over time, it learns how to navigate. So what happens when writing computer code is actually not a very good job, because we're actually more about raising products and raising physical spaces and things like that. It's a scary kind of world. So I don't want to belabor this point. I just think it's that this stuff is coming whether we like it or not. This is a program that one of my research labs is doing, where the robots, we just give it a final diagram or a final blueprint of what we want it to assemble, and the robot has learned overnight how to assemble it. So just like a child learning by playing with a bunch of bricks, we actually had it learn by playing with a whole bunch of bricks. We actually had it simulate a bunch of bricks, and then we had it learn this random pile of bricks could do things, and then over time, we asked it to learn how to pick up the bricks, how to look at them, and assemble them. Now, the interesting thing with machine learning is once one robot learns how to do it, it can be sent over the network, and many robots can do it. So this is what's happening in this space. Curiously enough, the heads of most of these machine learning teams, this is the person, Andrew Ng, who created Google Brain, have said, we are entering an era where lifelong learning is no longer an option. Because as these machine learning things start to take on tasks and new jobs, we need to actually learn all the time. We can't just say we're going to learn to high school or learn into college and stop and then just do the same thing over a whole life. We need to actually be lifelong learners. So that's kind of a little glimpse into what happens when we think about these things. And I think I said lifelong learners. I think this idea that we would go K through 12, from kindergarten, young child, maybe to get a degree and a certification, and do this in a very sort of if this, then that world, is all falling apart now. We're starting to realize that actually most of life is this kind of meandering walk into the future. And we learn every single step of the way, all the way from K through gray. How do we actually have a richer life to the point that we drop dead happy and smarter than ever before? So these are some of the things that we're looking at, and these are all coming together in different ways. We have machine learning, we have digital manufacturing, we have the Internet of Things, and I think what we're starting to see is co-creation, weaving those things together. And that's becoming a powerful technique, a powerful way for us to think about things. The next thing I want to talk about is sort of thinking about, great, we're here, but how do we actually build a culture of innovation that can embrace these kinds of disruptions? And so if you think about this rising complexity, and we just want to do the same thing that we've always done, maybe you could just put together a team and you can say, we'll just do it the same way we've always done it. This is the way we've always solved problems, we're going to do it this way. The problem is when you put together interdisciplinary teams, one domain expert says one thing, another domain expert says another, you think you're talking about the same thing, but you're really not, and you get some confusion in the process, and you end up with not a great solution. You sort of take a long time to get something done, and it's complicated. But when you really want to do new things, when you want to disrupt in new and dramatic ways, you have to think differently about what that team looks like. So when we're thinking about doing things in a new way, then things change. Now we have to say, how do we put together an interdisciplinary team of all the different stakeholders? How do we use those techniques I mentioned about design thinking and pull in people that are maybe very different than us? And how do we put them together in a way that we have people that understand how people think, so social scientists that can help us see how things work, people that know how things get done and you can build things, so the manufacturing community, the education community, and how does it get done from a policy standpoint, and then also how do you give it form and function, how do you use design, how do you use other tricks to actually do things. Ultimately, as I said earlier, all the hard problems are at the intersections of different places. And so we need to help find people that have wandered away and actually found new places to explore. A lot of people call these types of people T-shaped people. T-shaped people because they're jack of all trades. They kind of understand a lot of things, but they're actually very deep in one thing. And the benefit of a T-shaped person is that it sort of leads to trust. And I think later today we'll hear from Henrik and others about how do we build trust. If you're really good at something and you do something very different than I do, at least we know we can trust each other because you aren't just sitting around talking about it, you're doing something. And so T-shaped people are very powerful on your team because they actually they've maybe done everything they can in biology, and then they've realized they can't do it anymore. They're actually going to find new answers by wandering down and learning about computers, or by learning about something else. So they're curious minds. And I think the last thing I'll talk about is the creative spaces you can use. So how do we create physical spaces and reward environment spaces to change the way that we think about things? Every time you put together a team, every time you put together a group, it's like creating a new mind. So a famous cognitive psychologist, Herb Simon, said, a new mind is kind of like a pair of scissors. And this is a weird metaphor. But if you think about a pair of scissors, you can't cut paper with only looking at one blade. You need both blades, and they push against each other. And that's where it comes from. It's the emergence between those. And the way your mind works and the way a team's mind works is that the brain runs the rules. Each of the team members just does things, but they push against the environment. So think of ants don't have many rules inside of their brains. There are many neurons. But we then get rich complexity because they're pushing against gravity and the earth. And we get them farming fungus and maintaining anthills and things. So when we think about creating an environment that fosters innovation, it turns out the physical environment shapes the way we think. We can only remember 7 plus or minus 2 things in short-term memory, and if we want to be creative, only knowing 7 things at one time makes it very hard. But it turns out there's a hack to the way it works. If I look at your physical space, I'll probably see that you pile things all over the place. And that, you might think that's just a messy person. But it turns out that's the way we organize. The space remembers for us. Wherever something is located is what it is in our head. And when you look at creative environments, they often have very big spaces that you can be expansive in. And it's a phenomenon called where it is what it is. When you have a big conference room that looks like this is a top view of a conference room with a whiteboard and a projection screen and a table, it seems to say that one person standing at the podium is going to tell you all the answers. And you're not going to be able to collaborate. In fact, that whiteboard is hidden behind the projection screen. What we found is we can actually build these environments. This is a kiva from Native American culture in the Southwest. It's a large room that everybody in the community would come down inside of, and they would make new decisions. And in our laboratories, we have very large whiteboards because you can remember 1, 10, 100, 1,000, 10,000 things if you put it in physical space. So the space remembers for us. And when we do that, we end up having sessions that are only a day long, and we file for 5 patents, or we start doing new things. And so this is what a typical creative space looks like, where you have enough space to expand and you have enough space to work on. And these are also in some of the major universities and institutions, where people are able to expand and use their brains and use the space to remember. Maybe lastly, we have to think about a culture of innovation. So a team is born. And when a team is born, it actually needs leadership. You have to say, just like this group, building the future, you have to say, we're going to go that way. We're going to build more trust. We're going to think about things. But over time, the team evolves just like a child. The team wants to maybe have more competition and play. When you're first leading something, this is the head of Pixar, he said management's job is to prevent risk, but to build the ability to recover from risk. So you have to lead and say, I'm going to create a safe space. And I think that's what you're doing with your pilot programs. What's a safe space that we can recover from risk, we can consume risk, and we can learn from it without spending too much time on it so that we learn? But as the team evolves, you want to be more collaborative. As it gets to maybe teen years, you want to have more competition. And most of the great groups in the world actually do all of these things. They have leadership, they have competition, and they have collaboration. And they go back and forth over the course of the team as we're building these teams. And in fact, if you look at sort of the evolution of teams, these pilots don't last forever. A great group lives, thrives, ships, and then dies. If you look at maybe Martin Scorsese making a film, he puts together great people, he creates something amazing, and then they ship the film, and then everyone goes off and does other things. It's a very intensive thing. We heard this in Apple. Steve Jobs' teams would get together, they would do something amazing, they would self-destruct. And that's actually one of the rules of great groups. In fact, there are a number of characteristics of great groups that I will leave you with. And this is from a lifelong of study from a number of different researchers. Great groups and great leaders create each other. So there's a fallacy that there's this great genius person that can lead us into the future. It's Elon Musk or something. It's totally false. Great groups help you build a good leader. And great leaders help create great groups. They're sort of creating. Great groups are made of talented and diverse members. You have to get in people that think differently than you do. Every great group is an island with a bridge. You have to have an epic mission. How are we going to build the future? Great groups have an enemy, this idea that we're the underdog. This is the region and we're facing a lot of challenges. Okay, how are we going to do something about it? We also have to have autonomy to come up with our own ideas. We have to invest in ourselves with mastery, and we have to have this purpose to push us. And also, great groups just don't last. So I think I want to leave you with that. There's a long journey ahead in this process. As you're moving forward, I think it's important to engage in the ecosystem. It's important to think about all those techniques that I talked about at the beginning of putting people first. If you go online, you can find these techniques. You can find methods to do it. How do I get people on the same page? How do I generate breakthrough ideas? There are different methods to do this. It's been written up in many magazines how design thinking is changing the way we do business and changing the way we engage in things. But somehow we have to pull these things together. And if we do it right, we're also going to tell ourselves stories about the future. What's the new mythology? What's the new story about this region, about the Basque region, and about how thriving it is and how it's ready for the future, how it embraces the future, how it's created space for all of its citizens and for all of the stakeholders to thrive. And if we do that right, if we tell all these stories and we really get to the point of understanding what's possible, I think what will happen is we'll be able to navigate all that complexity because stories help us find a path into the future. And so I'll leave you with that and say this is a little bit of a map of the journey that you might come along and face as we move forward. Thank you very much.
Thanks to you, Mickey. Well, we better calm down our egos if we want to be in a great group, right?
Yeah. Well, that's the thing. It's this idea that the great leader, oh, let's go. Well, yeah, sometimes early on in a team you need somebody that says, let's go, and rallies the troops. But ultimately, you learn from everybody in the group.
Thank you very much.